So today we will be doing Coulomb's law, which is the next part in chapter 16. So we did about charge last time. So in Coulomb's law, we just have one equation. So we have this equation right here. So Coulomb's law gives us the force between two stationary charges. Stationary means the charges are not moving. But there are few things that you have to know when you are applying this equation. The first thing is we will be using the equation, this formula, only to obtain the magnitude of the force. So this formula will give you the magnitude. So when you are plugging values to this equation, you have to make sure that you are only substituting the absolute value for the two charges. So that is why we have this magnitude symbol on either sides of Q1 and Q2. So whenever you are using Coulomb's law, whenever you are using this equation, you will be only plugging the magnitudes for Q1 and Q2, and this will result in the magnitude of the force. However, we know that force is a vector. So what is a vector? A vector is something which has both a magnitude and a direction. So how do we obtain the direction of the force? So to obtain the direction, we have to inspect the charges. For example, we know, let's say we have two positive charges. So we know when we have two like charges, they repel each other. So if you are asked to calculate the force acting on, let's say, this charge, then what you will be doing is you will apply Coulomb's law. You will apply this equation to obtain the magnitude. And then by inspecting the charges, you will figure out the direction. So here the direction is positive x direction. If you have two negative charges, they too repel each other. If you had opposite charges, they will be attracting each other. So the most important thing is that you will only use this equation to find the magnitude, and then the direction will be determined by inspecting the charges. And if you look at this image here, you can see that I have used F12 for the force on this charge and F21 for the force on Q2. So it's easy when we use this nomenclature, like this represents force on 1 due to 2. So force on the first charge, Q1, due to the second charge. However, what you have to remember is they are equal. So using Coulomb's law, you can get the force between two charges, and two forces are equal in magnitude, but they will be opposite in direction. So when they are the same, the directions will be opposite. When they are opposite charges, still the directions will be opposite, but they will be attracting each other. So Coulomb's law will give you the force acting on the two charges, and no matter how different your charges are, the force acting on each will be the same. For example, let's say we had a huge charge here, capital, let's say capital plus Q, and we had a tiny charge here, which is Q. So force acting on both of them will have the same magnitude. Only the direction will be different. So what is this K? So before we move forward, what is this K? K is the Coulomb's constant, and it is a constant. Most of the time, the value for your constant will be this, 9 into 10 to the power 9. And K is given by this equation. Epsilon naught for free space is given by this value. So in the exams, usually they will give you the value for these two. So what is this R? Before we move forward, what is the R? R is the distance between your two charges. So when you are finding R, you have to remember that distance between the two charges means the distance between the center of gravity of each of the two charges. So it's not this distance, it is this distance. Okay, so let's move to the first problem. So this is a very simple problem, and this will explain us how to substitute in the equation. So the first problem asks you to find the magnitude of the force. So we have two charges. One is 25 microcoulombs, and the other one is 2.5 millicoulombs. And both of them are positive. And also they say that the distance between the two is 16 centimeters. So it's an easy problem. So they're asking for the magnitude. So we know to obtain the magnitude, we just have to use the Coulomb's equation. So this is the Coulomb's equation. And we need to substitute the values. K. K is the Coulomb's constant, which is 9 to the power 9, 10 to the power 9 Newton meters per square coulombs. And your Q1, so this is very important, your Q1 is given in microcoulombs. So whenever you are plugging Q1, Q2 or R, anything to this equation, you have to make sure that your charges, your units are in standard units. So here 25, since it's microcoulombs, we need to convert it to coulombs. The conversion factor is 10 to the negative 6 coulombs. So this is Q1 and Q2 is 2.5 milli. Milli is 10 to the negative 3 coulombs. And in the denominator, you have R. So your R is, the distance is 16 centimeters. You need to convert it into meters, which is a standard unit for a length. Then you take the square of it. So when you substitute the values, you will get the answer 21973 newtons. So you can see this C to there we have a C squared, Coulomb squared here. It will get cancelled off with these two, and we have the denominator in meter squared. It will get cancelled, and your answer will be in newtons. So in the second problem, let's say this is A and this is B. We have two small charged spheres that are 6.52 centimeters apart. So they have given us information about two charged spheres. They are 6.52 centimeters apart. And what do? They move them such that the force exerted on each other is tripled. So to increase the force, we know they should come closer, right? So we don't know whether they are positive or negative, but they have moved them such that the new force, let's say this is the old force is F, the new force is 3F. So there are multiple ways that you can do this problem. So I will do this problem in a way that you use least amount of math. So for this one, let's say the force exerted is F, and we know it is given by Q1, Q2 divided by the distance between the two. So it is 6.52 centimeters. So, but I will call it R1 for now. And I'll call the new distance R2. So this is my first equation. In my second equation, still my charges are the same, but the distance is different. So they're asking us to find this new R, right? So there are multiple ways that you can do this problem. So what I will do right now is I will divide the two equations. So what will happen when we divide the two? So I'll do a division sign here. So when I divide this, I get F. So I'll write it here. F divided by 3F. And what will happen to this? So we have K, Q1, Q2. I'll write it as it is, K, Q1, Q2, R1 squared. And we know when we divide this part comes to the denominator. And this R2 squared come to the numerator. So division is similar to multiplication by the reciprocal. So we can say that K, Q1, Q2 is common. So it get cancelled, and this F get cancelled with this, and you are left with 1 over 3 R2 squared divided by R1 squared. So they're asking you to find R2, right? So when you make R2 the subject, that means you are cross multiplying. You get R1 squared divided by 3. When you take the square root, you get R1 divided by root 3. So when you plug the value of R1 to this equation, what do you get? So I'll rewrite what we got there. So R1 divided by root 3, R1 is 6.52 centimeters divided by root 3, it gives you 3.76 centimeters. So the answer should be given in 3 sig figs because this has 3 sig figs. Here the slide, and we'll all try to do the B part. So in part B, it is a similar question to part A. So what are they saying? So they say that there are two objects and they attract each other. That means they are similar charges, right? With a certain force. Okay. If the charges on both objects are doubled with no change in separation. So what does that mean? So the initial distance between the two is r and they are not going to change it. So still the distance is r. Instead, they double the charges. So if this was q1 and q2 initially, now the charges are 2q1 and 2q2. Still the distance is the same. So they are asking us what will happen to the two forces. So I'll name this F1 and F1. I'll name this F2 and F2. So can we write F1? F1 is given by K, Q1, Q2 divided by R squared. In the same way, we can write F2. F2 is K, but the charges are doubled. Q1, 2, Q2 divided by R squared. So when we rewrite this, we get 2 times 2, 4. K, Q1, Q2 divided by R squared. So what is this? This is same as F1, right? That means your new force F2 is 4 times your old force. So the answer is A. So it's a very simple problem. So let's move to the third problem. So I'm going to draw the diagram. There are 3 charges. The first charge is 65 microcoulombs. I'll name it Q1. And the second charge is plus 48 microcoulombs. And the third charge is negative 95 microcoulombs. And they're saying that the center one is 0.35 meters from each other. So this distance is 0.35 meters. And this distance is 0.35 meters. So they are asking us to calculate the net force on each charge due to the other. So let's first look at Q1. So let's do 3 charges separately. So if I draw Q1 here, what are the forces acting on Q1? So from Q2, it is going to be repelled this way. So I'm going to name this force F1, 2. This is a force on charge 1 due to charge 2. And in the same way, it's going to feel a force from Q3, which is an attraction. So it is F1, 3. What about Q2? So on Q2, we just saw that F21x. F21 means the force acting on the charge Q2 due to Q1. It's a repulsion, it's this way. So due to Q3, it's going to feel the attraction, and I'm going to name it F2, 3. In the same way, I'm going to draw. So sorry, this is charge Q2. This is charge Q3. On Q3, there are two attractive forces from Q1 and Q2. So there are two forces acting this way. One is one is F3, 1, and the other one is F3, 2. So we know the forces acting on each other. So what I drew here are the 3 directions for each of the 3 charges. So let me now calculate the 3 forces. So we know F12 is same as, the magnitude of F12 is same as F21. In the same way, F13 is same as F31. And F32 is same as F23. So I'm going to find these 3 and then add or subtract them accordingly for each of the charges. So F12, it is K. So if I write the Coulomb's equation here, K, Q1, Q2 divided by R squared. And K is given by 9, 10 to the power 9. So K is 9, 10 to the power 9. Your Q1 is 65 microcoulombs. I just converted microcoulombs to coulombs. And your Q2 is 48, 10 to the negative 6 coulombs divided by the square of the distance between the two. So if you do this, you should get the answer. So let me So the answer I got is 229 microcoulombs. So in the same way, I'm going to do these 2 parts. 65, 10 to the negative 6. My charge 3 is 95, 10 to the negative 6. So here you can see I'm only substituting the value. I'm just putting the absolute value because I know the Coulomb's equation only gives me the magnitude. So I don't care about this negative sign. So the distance between 1 and 3 is 0.35 plus 0.35, which is 0.7 to the power 2. So the answer I get here is 113.4 newtons. So this one should be newtons. I have put microcoulombs. So in the same way, we can calculate this. My charge 2 is 48 microcoulombs. So I converted it to coulombs. Third one is 95 divided by the distance between the two. So I get the answer as 335 newtons. So I have the values for F12, F13 and F32 forces. So now it's a matter of getting the final answer. So let's assume that my positive direction is positive x direction. So here my force so here the force acting is, we know F12 is bigger than F13. Therefore, the net force is along the negative x direction. So I'm going to write it as F12 minus F13. So these are just the magnitudes. So F12 is 229, F13 is 113. So when you take the difference, you get 115.6 newtons in the negative x direction. Go this way. So here both of them are in the same direction. Therefore, you can just simply add them. So F23 plus F21. F23 is 335. F21 is 229. So it will give you 564 newtons in the positive x direction. So in this direction. So if we look at the third one, both the forces are along the negative x direction. But since they are both in the same direction, you can simply add them. So you will be adding F31 and F32. So your answer will be 113.4 plus 335. 448.4 newtons. but it's in the negative x direction. So when they're asking for the net force, you have to remember that a force is a vector. That means you need to give the magnitude and the direction. Okay, so here we have a triangle. And if I read the question, 3 positive charges of equal charge, 17 microcoulombs, are located at the corners of an equilateral triangle of side 15 centimeters. So there are 3 charges and all the charges are positive on 17 microcoulombs, 17 microcoulombs, and each side is 15 centimeters. So they are asking us to calculate the magnitude and direction of the net force on each particle due to the other two. So when looking at this diagram, you can see that all the charges feel very similar forces from each other because this is an equilateral triangle. So it's easy to derive the answers using symmetry. So what we will be doing now is we will only calculate what's happening for the first charge. So I'll name them 1, 2, and 3. Let's do the problem just for the first charge, and then you will see that it's the same for the other two. So the first charge. The first charge here is going to feel a repulsion from the second charge, right? So it's going to feel a repulsion. Why? Because they are both positive. So it should be along this line. So I'll erase this and redraw this nicely. So along this direction, you feel a charge from the second one. So I'll call it F12. And in the same way, from the third charge, it's going to feel a force, a repulsion in this direction, F13. So I'm going to redraw it here, F12 and F13. So what can you say about F13 and F12? They are equal, right? So they both have the same magnitude because F12 is created by 17 microcoulomb charges and the distance between the two charges is the same. So the charges, the charge magnitudes and the distance between the two charges are the same for F12 and F13. F12 and F13. So they are having similar magnitudes. So I'll write it here, F12, F13, and even F23 are having the same magnitude. So when we get a problem like this, what can we do? So if this angle is 60, what can you say about this angle? It is also 60. Why? Because they are vertically opposite angles. So this whole thing is 60. Since the y-axis is the bisector of the angle, this angle is going to be 30. This is going to be 30. Okay, so what we need to do is we need to take the resultant or the superposition of the two forces. So how do we do that? So the easiest way that you can do is you look at the x component and the y component of each of the two forces. So let's look at the first one, F12. So F12 is along this direction, therefore the x component will be F12 sine 30. Or even you can write it as F12 cosine 60. So both are correct. So in the same way, along the y direction, it has F12 cosine 30. So now I'm going to look at F13. So the x component is along this direction, right? So along this way, it's along the negative x direction. So what you get is F13 sine 30. However, it is negative. We have this negative sign in front. So along the y direction, it is cosine 30, but it's pointed in the positive y. So you can see that these two get cancelled because we know F12 and F13 have the same magnitude. And since they are opposite to each other in direction, they are going to get cancelled. So you don't have any x component. So when you add these two, we know F12 and F13 are the same. They have the same magnitude. What you get is 2 times F12 or 13, anything, cosine 30. And both, this is detected in the positive y direction. Positive y direction. So the next step is figuring out what F13 is. So if you have the value of F13, then we have to just substitute it here to get the answer. So using Coulomb's law, K is 10 to the power 9 times 10 to the power 9, and your two charges are 17 microcoulombs and 17 microcoulombs. So 17, 10 to the power 6, and again you have 17, 10 to the negative 6. And the distance between the two charges is this, right? So it is 15 centimeters. So 0.15 meters to the power 2. So when you do this, you get the answer as 115.6 newtons. So that is just F13. So of total answer, the resultant force will be F net. They're asking for the net force is 2 times F13 is 115.6 times cosine 30. So your answer will be 200.22 newtons. Okay. So they are asking us to calculate the magnitude and direction on each of the three charges, right? So I just found the magnitude. So we know all the three charges will feel the same. So the magnitude will be 200 for all three, but the direction will be a little different. So I'll use a different color to show the direction. So for this one, it was along the positive y direction this way. So for the third charge, it will be along this direction. For the second charge, it will be along this direction. How did we know the direction? From symmetry. We know from this one, the force will be like this way from the first charge. And from the second charge, the force will be this way. So your resultant force will be this way. Okay. So now let's move to the fourth problem. At each corner of a square of side L, there are point charges of magnitude Q, 2Q, 3Q, and 4Q. So they increase the value in clockwise direction. So it's correct, right? Q, 2Q, 3Q, 4Q in clockwise direction. Determine the magnitude and direction of the force on charge 2Q. So on 2Q, it's going to feel. So I'll name this the first charge, second charge, third charge, and fourth charge. So 2Q is going to feel a repulsion from this Q charge, right? Because this is also a multiple of Q, 2Q. So they have the same sign. They're either positive or negative. Because they have the same sign, they are going to repel each other. So I'm going to name this F21. Force on 2 due to 1. So in the same way, it's going to feel a force due to the third charge here. So I'm going to name it F23. So due to the fourth charge, it's going to feel a force in this direction, and I'm going to name it F24. So we have three forces acting on this charge 2Q, and to get the net force, we will have to take the resultant. So what can we say about this length? How can we calculate this length? We will need this length to calculate F24, right? Because the distance between 2Q and 4Q will be this length. So what will be that? So using Pythagorean theorem, we know if this is L, so these two sides. This side, the hypotenuse should be L squared plus L squared, and then take the square root. So this distance will be root 2L. So root 2L. So now we know all the distances. Now it's a matter of finding each of the forces and then taking the net force. So let me first find out the three forces. F23. F23 is the force between 2q and 3q. So it will be K times 2q. So I'll put a bracket 2q into 3q divided by L squared. So what you get is 2 times 3 is 6, 3k q squared divided by L squared. So in the same way, for 2, 4, you get k 2q times 4q divided by the distance between the two, which is root 2l to the power 2. So when this root 2 gets squared, this will be 2l squared. So you can cancel the 2 with this 2 and you get 4k q squared divided by L squared. As for F21, you get k q times 2q divided by L squared. So you get 2k q squared over L squared. Okay, so we know usually what we do to add three forces. We take the resultant or the superposition. So the easiest way, like I said before, was to take the x and y component of each force and then take the resultant of those two. So from F23. So we know F23 is anyway in positive y direction. So it is 6kq squared divided by L squared. What about F24? F24 is in this direction, right? So it is not either in x or y. So we need to find this angle to figure it out. So can someone tell me this angle? What should it be? So this angle is same as this angle, right? Vertically opposite. So how to find this angle? If we take tan theta, you get L divided by L, which is 1. So theta is tan inverse 1, which is 45 degrees. So another easy way that you can find this theta is, we know this is 90 degree, right? So when the two sides are equal, this becomes a isosceles triangle. So in isosceles triangle, these two angles are the same. So if this is 90 degrees, this should be 45 and 45 each. So anyway, we now know the value of this theta, which is 45. So in along x direction, you have F24, which is 4k q squared divided by L squared times cosine 45. And along y direction, we have the same thing. Why is that? Because we know sine 45 and cosine 45 are the same. But I'll just write sine 45 not to confuse you. So let's look at the last force. The last force is along x direction. So you get 2k squared divided by L squared. So now we have figured out the two forces along x and y direction. Now we have to get the net force along x and y. That means we just have to add these two. So what do we get when we add the two? So you can see that k kid squared L squared is common. So you have to add 4 cosine 45. What is 4 cosine 45? 4 cosine 45 give you 2 root 2. So 2 root 2 plus 2. 2 comes from here. Times k kid squared divided by L squared. So in the same way, here also you get 2 root 2. And from the first force you get a 6. Okay, so I'm going to write it nicely here. So now you have obtained the x and y components of your resultant force. So if I simplify this, what I get is along x direction I get 4.82 k cube squared over L squared, and along y direction I get 2 root 2 plus 6. So I get 8.23 k cube squared divided by L squared. So how can we obtain the resultant? So since we don't have much room, what I will do is I will go to the next page and redraw this diagram. I will redraw this diagram in the next page. So how do we obtain the resultant of these forces? So we know it is like obtaining the resultant of a right triangle. So this will be your resultant, and your net force is the resultant is given by fx squared plus fy squared. So your fx will be 4.82 k cube squared over L squared. So you need to take the square of the whole thing. And your y will be 8.83 k cube squared over L squared. And then take the square of the whole thing. So you can say that k cube squared L squared is common to both, and it is also squared. And when you take it out of the square root, you get the exact same thing. And inside the bracket, you have the square of 4.82 and 8.83. So I get the answer 10.06 k cube squared L squared. So this is the magnitude of your force, but you need to get the direction. So you need to tell what this angle is. So I'll name it theta 1. So your theta 1 will be tan inverse. When you are obtaining tan, it is y divided by x, right? So your answer will be tan inverse 8.83 divided by 4.82. So you can write this k cube squared over L squared here, and here you can see that they get cancelled. So that's why I just wrote the two numbers. 61.37 degrees. So we have done this problem now. You have the force, the magnitude of the force, which is 10.06 k cube squared over L squared along this direction, which makes 61.37 degrees from the positive x direction.